All right, what the crap are we looking at here? These three equations are exactly the same equation. They've just been manipulated. So if you want distance, you can just use this formula. If you want time, you could solve for this formula. You can solve with this formula. Or if you want rate, you can solve with this one. But you kind of have to figure out which one you're going to have to use for these motion applications, okay? So again, are you going to pick this up very quickly? Probably not. But if you do enough of it, you will. But what I'm saying here is you may have to take some time. You may even have to do some guess and test. Like maybe you thought it was rate, but you see that doesn't work. Okay, well then go back to time and then do that one. Okay, that didn't work. Try the distance equals rate times time. We've seen applications of this like the rowing up the stream or the airplane going on a trip and then back against the wind, right? Like, okay, if your distance is the same, you said distance equals distance, and if that happens, that's fine. But sometimes, again, you just may have to add these together. We'll see. Here we go. A boat, which moves at 25 miles per hour in water without a current. So we know the speed of the water without a current for some reason. But it goes 60 miles upstream. That's the distance it's going upstream. And when we see upstream, I'll make a note of this just so we can remember this. But upstream is against the current. All right, that'll be important to know. And then it goes 60 miles back again. Now, if it's going upstream first, then if it goes back, that would be when it goes back. Let's see if I can do this right. When it goes back, it is going with the stream, the current. I think they call that downstream. There we go. So when you go back, you're going downstream. And the current is pushing you towards your destination. But we do know that it goes, when you go back again, it looks like it's going to take you 5 hours to go that 60 miles. But what we want is the speed of the current to the nearest tenth, okay? Oh, so I apologize. I was thinking that was just the downstream trip. This is both. So, and again, this is the importance of reading and rereading these. But you got 60 miles upstream, and then you got 60 miles downstream, and this is how long it takes you to do both, okay? So I'm going to separate these. We got two parts to your trip. You're going to go upstream. By the way, I haven't really determined which of those formulas I'm using. Upstream. Okay, then you're going to go downstream. This is the return trip, or going back, but this would be downstream. Okay, and again, it was talking about time right there. So if you take your time for upstream and add it to your time downstream, this is the total trip. Total trip time. There's a name for that. 3 T's together like that, but I don't know what it is and I don't care. So, I'm assuming that we're looking at the time formula on these, okay? So the time should be the same as taking the distance and dividing it by the rate. D equals RT, yeah, so divide both sides by R, okay? Time is the distance divided by the rate, okay? And again, how do I know this is time? It's because it gave us the total trip in time, okay? So I'm expecting my upstream time and my downstream time, but it's in relation to your distance and your rate, okay? So if I look at your upstream time, distance, your upstream time is distance over your rate. Your distance, it said you went 60 miles upstream, right? Okay, your distance is 60. You can label that miles if you'd like. But the rate, this is where we get a little bit of confusion because it's like, well, it didn't tell us how fast you were going. And some students just mistakenly say, well, you were going 25 miles per hour, right? Well, you were, but that was only part of your trip, right? That's the boat in still water or without a current. So what we have to do here is we gotta apply the current, and since you were going upstream, you were going against the current. So I'm using the variable c in this case. Again, c should represent what we're solving for. That's the speed of the current. Okay, so I've already got a c with my upstream ratio, distance over the rate. Okay, well that's good. What about downstream? Well, again, I'm looking at it as a ratio because time is going to be distance divided by the rate. Well, it's the same distance though. You went the same 60 miles back again. So that's going to be 60 over, again, you have the speed of your boat because that's your rate, but now you're going with the current, so it's adding to your speed. So that's the representation of both times, both for upstream and downstream. If you add those two times together, the total trip took, it said, 5 hours. Well, yeah, we do want to see the denominator for the 5 because we're going to force the denominators to match, and then we're going to get rid of them. So I can't just apply like those last problems with the work. I can't just say, well, each of these just missing a c, so I'm just going to tack on a c with the 1. I can't do that because this is 25 minus c, 25 plus c. So we're really looking at binomials on this. So let's apply them as binomials. So I really have two denominators here that I got to worry about. The 1, not so much, right? So I'm going to take that 25 plus c, and I'm going to apply it to the 25 minus c right there. And by apply, I mean I'm going to multiply it. Sorry if the writing's kind of small, but this is 25 plus c. I'm going to multiply it there, okay? Because that fraction was missing a denominator, 25 plus c. But don't forget, if you apply to the denominator, you got to multiply by the numerator as well. So 25 plus c there. And so yeah, sorry this is written poorly, but again, this all is in an attempt to get rid of the denominators anyways. Okay, so now I look at this fraction. It's got the 25 plus c. Now that we've applied it here, it's there, but we're now missing the 25 minus c. And by the way, this should look like that difference of squares, the end of that, right? So I've multiplied the denominator by 25 minus c. Now I've got to multiply it by the numerator as well, 25 minus c. Okay, so over here on this part of the equation, I have matching denominators, but this denominator over here, which is a 1, which we showed, it's now missing both of them. But I'm going to do one at a time, okay? So I'm going to apply the purple one first, just because I guess that's the one I started with. Doesn't matter which one you start with, though. So 25 plus c. Again, if you do it to the denominator, please do it to the numerator as well. And then I got to multiply it by the other denominator of 25 minus c. In both the numerator and denominator, okay? And again, all I've really done here is I've multiplied it by 1 and 1. It's just, what did I want 1 to be? Well, I forced it to be this. Okay, so this one has a 1, and if you're really confused by that, understand that all of these are being multiplied by 1s. It's just we don't have to show them, okay? But what I've done there, I've now forced the denominators to match, which is what we wanted. Because once they match, I don't need them anymore. So I'm going to rewrite this equation without any denominators. So that was in the numerator, the first numerator, 25 plus c times 60. And then that would be added to the other numerator, which was 60 times 25 minus c. And then this equals all that stuff. Let's see if I can just copy it. I'm satisfied with that. Okay. And again, I do apologize. I did put the 25 plus c on the left side. Hopefully that's not a problem. We know we can distribute from the right parentheses because it's just multiplication. So hopefully that's not too bad. But I am in the process of I need to now be in the process of distribution, right? I've got the 60 first, so I'm gonna have to multiply 60 by 25.
1,500.
Thank you. Got a human calculator here, you know. So, and then 60 times c, 60c. Okay, well, that's the first distribution. Let's distribute this other 60. Well, the good news is 60 times 25 is still 1,500. And 60 times negative c would be negative 60c. And that was pretty good, right? But we got a lot of distribution on the right. So let's Get that simplified. I'm going to start with distribution of just the binomials, which some people prefer to call FOIL. And if you do, that's okay. So 25 times 25 is 625. We forgive you, you know. And then we got the 25 times the negative c would be negative 25c. Again, we are expecting this to be a difference of squares there. And then the distribution of this c times that 25 would be positive 25c. See how it gets that? Those two middle terms zero out. And then c times negative c would be negative c squared. Okay, so I did zero this out. I'm not applying the 5 yet, by the way, because I don't want to. Because I would like to simplify the inside here first, which I just did. And now, the inside of that parentheses is 625. Probably gave myself more space than I need. Times minus c squared. But now I will look at the times by 5, okay? Like I said, I'd like to get rid of that. And yeah, we do have some like terms on the left to combine as well. We'll get to that. But I'm going to distribute the 5 there. And yep, I do need more space. So I got 5 times 620. Oh, crap. Typed it in wrong. 5 times 625, 3125. And then 5 times negative c squared would just be negative 5c squared. That's pretty good. All right, this all equals the stuff that we had before, but I know on the left that if I were to combine my 60c and the negative 60c, that just zeroes out. So those just zero out. But what I will then do is I'm going to take this 1,500 plus 1,500, which would be 3,000, right there. I will mention this before I proceed. Okay, you could have kept this like this and then divided both sides by 5 if you wanted to. Again, you're just using principles of equality because now I'm in principles of equality. But whether you notice that or not doesn't matter because you can do it, but you don't have to. Like I did, I distributed. But right in here, what I would like is the c squareds by themselves. So I want that 3125 to be gone. And by gone, I mean zero out. So I'm going to subtract 3125 from both sides. That would give me negative 125 on the left, which now equals, I'm going to drop the negative 5c squared. Okay, because we zeroed out the 3125 in green as we planned. Unfortunately, I need more space, just a little bit more. But now that we're at this point, we're going to solve for c squared. Now remember, we do want just c though. That's how we defined it up there at the top. So we're gonna have to do something after this. But first, let's divide both sides by negative 5. And it appears to be then 25 equals c squared. Well, that's nice actually. Because all I've got to do at this point is square root it. Okay, now you could say in this case, c, it could be 5 or negative 5, but this is a word problem. And so even though the numbers are the same, I don't really care about the negative 5. I was just looking for the primary root there because it's a word problem. You couldn't say that the speed of the current is negative 5 miles per hour. I mean, you could if it, you know, because we were going with or against the current. But really, we just want the 5 there. So C, that was the speed of the current, 5 miles per hour. That's all you got to put. But if you want to say 5 miles per hour is the speed of the current, now that I've said it out loud, let's go on. 5 miles per hour, the speed of the, again, I would never expect anyone to write all this on a test, but you could. The speed of the current is, I think it was miles per hour, right? 5 miles per hour? Miles per hour, yeah. There at the top, right? So yeah, we're good. So this part, I think, I don't remember seeing this recently. I'm not saying we haven't seen it, but I just don't remember when we did. And so we haven't seen this in a little while. Again, if you got a c squared, you're going to make that a c by simply square rooting both sides. I did change the position of the c, by the way, in the equation. I'll show that extra step. So it would have shown c equals 5 right there. I know, right? So I just switched the c and the 5. I don't know. It makes me feel better inside, I guess.